right, geometry. My goal was to get done with chapter 7 before I go outside. So let's get this done. This is section 6 of chapter 7. It's parts of similar triangles. And there's basically 3. There's another one, I guess it's just a little extension. But let's take 2 triangles, okay? And we'll say that these 2 triangles are similar. How's my triangle drawings? Getting better. Okay, so we're saying that these 2 are similar. A, B, C, X, Y, Z. Okay? So let's take the altitude. Remember, the altitude is what goes at 90 degrees up. Altitude, 90 degrees up. So what theorem 7.8 says is that the altitudes are going to be similar to the sides. And I guess it's just a fancy way of saying is if these 2 triangles are similar, then when you draw an altitude, are those 2 triangles similar? Because if they are, then you know that the sides are going to be proportionate, right? And I think if you look at this, we can quickly prove this by the angle-angle theorem. We know that the 90-degree angles are the same. And we know at the very beginning when we had this big triangle and this big triangle, we know that this angle was the same as that angle because they're corresponding. And so you've quickly got 2 angles that are the same, so you can prove that this little triangle is similar to this little triangle, so therefore their sides are going to be proportionate. We could do the exact same reasoning to do this half. Let's see, do I have another color pen? We could do the same reasoning for that half and that half. And so we could prove that like that's proportionate to that. Okay? And you could, likewise, you could prove that the 2 altitudes are proportionate. Okay, that's 7.8. 7.9 is slightly more difficult. Let me just draw kind of a different looking triangle. What 7.9 says is if I take the angle bisector, so see that angle and I bisect it. I cut it exactly in half. So now it says that these parts are going to be proportionate. Basically, what it's saying is that if you did that, you're cutting this into a similar triangle as this. And same with the other side. The blue sides are going to be similar, and the red sides are going to be similar. Well, we can prove that real quick. Kind of the same thing I just did. Okay, this angle we already know is going to be equal to that angle. If this whole angle is equal to that whole angle, and now I'm just taking half of it, well then that's going to be equal to that other half. So by the angle-angle theorem, I can prove that this triangle is similar to that triangle and vice versa on that side. So the parts are going to be proportionate. Okay, last one, or not the last one, but almost last one. 710 says we're not going to do angle bisectors, we're not going to do altitudes, we're going to do medians. Do you remember what medians are? So let me do kind of a different looking triangle. Whatever. Medians cut, like, see this side here? they're going to cut this exactly in half. And they're going to cut this side exactly in half. So now these two are going to be the same. These two are going to be the same. So theorem 7.10 says if you have two medians, that they're basically cutting these into similar triangles. So if this triangle was similar to that triangle to begin with, the median is going to cut that into a similar triangle as that. And the other side too. So let's think about how we could prove that. Well, we can see here that this angle was going to be, it's already equal to that because of the bigger triangle that had to be equal to that. We can see that this side right here was similar to this side because of the bigger triangle similarity. And this whole length here was similar to that whole length there. And so now if we cut this exactly in half, well, if the whole length was similar and we cut it in half, then that half length is still going to be proportional. So these two triangles. So 7.10 says if two triangles are similar, the lengths of corresponding medians are proportional to the lengths of corresponding sides. Okay, so I think we can handle those. 7.11, I have to admit, I've puzzled over this a little bit, and I don't really understand how this is very much different than 7.9. All right, 7.11, sorry. Let's look at 7.11. 7.11, and maybe by this time next year when I'm teaching this, I'll understand this better, but I don't really understand why this is a different theorem. 7.11 says that if you have a triangle, it says an angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. So let's bisect this angle. We're going to bisect it, comes down, boom. So it says that it separates now, let me draw them different colors. This length and that length. This length and that length. These two are going to be proportional to these two. But you see how we just proved that if you had, well, okay, maybe I get, it's a little different because we're not talking about two different triangles. But we can prove that this triangle is similar to that triangle, right? That angle is going to be the same as that. That side is going to be similar to that side. And that side is the same. So we've got side, angle, side. Anyway, 7.11 just says that an angle bisector splits the two triangles into two similar triangles. Okay? All right, that is it for chapter 7, and I am out.